Welcome to the Future of Everything. I'm Russ Altman. Thank you for understanding that we are still under pandemic broadcasting conditions and therefore apologize for any small or large technical glitches in the sound quality. Today on the Future of Everything, the future of the water supply. As we all know, access to water is critical for human existence. If you look at maps, you can see that most major cities were founded near a water source. Many are associated with their famous rivers or lakes. Innovations in healthcare came by managing the safety and cleanliness of the water supply, helping especially to manage infectious diseases. There are some amazing water projects, infrastructure projects, dating back thousands of years, such as the aqueducts built by the Romans and others. There have been aggressive efforts at desalination of water, of salt water, with some countries having very advanced capabilities in these areas because it's so critical for them. Water is important everywhere, and particularly in the United States West. The movie Chinatown, which some believe to be a model for excellent screenplays, I am told, portrays the politics of water rights in Southern California and many other things, and I highly recommend it. But water is changing. The way it accumulates, the way it is distributed, and usage patterns. And so policies and approaches must change as well. Dr. Newsha Ajami is a senior research engineer at Stanford, and she's director of the urban water policy at Stanford's Water in the West program. Newsha, thanks for being here. You have studied the changes and challenges to the water supply from many perspectives. Can you tell us about the most dramatic changes you've seen and how it impacts our planning for the future?
Sure. Thank you for having me, Ross. Good morning. I really like your monologue because you mentioned how cities are built, used to be built around water sources. And actually, the interesting pattern that we have noticed in the past 100 years is now that we have more sophistication as building infrastructure, people can live wherever they want. And then we have been putting a lot of effort and engineering solutions in place to bring water to them. So California is a great example of that, and Chinatown is a great movie because it sort of demonstrates that process.
And people care deeply.
People care deeply, exactly. Wherever the water is coming from, the people who are in that locality really depend on that source, and people who actually end up moving to these areas that we move water to are going to depend on it for the years to come. So, in California, as I said, a lot of the coastal towns depend on these resources that's coming from far distances. Now, this infrastructure was built based on assuming that we can use snow as a natural reservoir that would hold water for us during the cold seasons, like late fall, winter time, and then we will get as spring comes along, the reservoirs, the snow start melting, and then the water ends up filling up the reservoirs, and we use that extra water for summer, late spring and summertime. This was great if it would work forever and ever, but first of all, and so this assumption is called we assume the system is a stationarity, so we can always get the same thing over and over. It will repeat itself the same way.
Relatively predictable.
And
let me ask, is that a model specifically for the Western United States? It sounds like it might be different on the East Coast. Do they have the same model of stationarity in the East Coast as well?
Same model, different elements, I would say. Some reservoirs depend on snowmelt as a way of filling up during the spring and summer. Some reservoirs are mostly dependent on rainfall during the whole year or during monsoon season. So reservoirs have been sort of our way of holding water and gradually releasing it based on need whenever we need it. And so that has been sort of like opportunity to use that infrastructure for this purpose. So what we see now is actually because of climate change, the climatic patterns have significantly shifted and changed and altered. So for example, in areas that we depended on snow, some areas we don't get as much snow that we used to. We get a lot more rain, which means that whole equation has changed.
Right.
Or
you run out in June or May.
Exactly. Or actually maybe earlier. And sometimes actually, and also the timing of these precipitation patterns have shifted. So we used to actually use these reservoirs, interestingly enough, to manage to do flood management, right? So during the rainy season, that the infrastructure would be used to slow down the water to make sure that some of the cities that are downstream don't get impacted by the natural disasters due to flooding. But now we get more rainfall than snow we used to. Yes. Now we have to release it faster, which means then we are not going to have enough water later when we need it during the warm season.
That's a very easy to understand problem. And anybody who's been up in the snow knows that these patterns are changing. But are we just like in big trouble, or are there things we can do? I mean, it sounds like the fact that the water is changing both in amount and character, that's a big problem. And I can't imagine. So what are the approaches to managing this?
So actually, that's a great question. Couple of things that can happen. One thing I want to emphasize is some of these systems that we built was sort of top down, right? So some, engineers got together, decided that's how we're going to build it. You and I, who are the consumer at the end of the pipeline, we were not necessarily part of this process. Our need and demands were aggregated as one big lump demand that they need to meet. And we were sort of also assumed to be predictable. So we use the same amount of water the whole time. So we were not part of this equation. As we are experiencing this sort of extreme events, that means that we need actually everybody in this chain of command to be part of the process, including us as consumers. So the solutions actually are, depending on which part of the system you're looking at, can be different. One is, if you're looking at a centralized system, we have to rely more on natural systems to store water in different ways. For example, in California, I'll give you an example for California, we have a lot of groundwater basins that have been overdrafted or overused for consumption. Some of them can be used for storage. As we get more water, we can move it down earlier and store them in these groundwater basins. The two positive things about groundwater basins being sort of recharged is, one is it's avoiding, stopping them from subsidence, which is a big issue.
Everything is just, you don't want everything to just
No, sink. And you don't actually want to lose the storage there, right?
Right.
And the second thing is they don't have a significant environmental footprint that the large reservoirs and dams have. We are not putting different beautiful valleys underwater to hold the water, or actually moving people around to enable that space to be available for storing water.
Yeah, I'm not sure I appreciated that you could refill these natural underground sources, but it kind of makes sense. It would be by the normal processes of rain and meltage just seeping in. Right. Can you accelerate that? Are there engineering approaches to kind of, I don't want to sound too crude, but like pump it in?
Yes, actually, there are ways that you can actually inject it back.
If you're in a rush.
If you're in a rush. But, if you think about it, the fascinating part of this changing environment is we are learning that nature actually by itself had all the solutions within it. We just had to be more closely work with it. And instead of and I'm an engineer, so I can criticize engineers, instead of trying to engineer our way out of our limitations, actually work with nature.
Yes.
To be our ally in this process.
So you made a very compelling reference. By the way, this is the future of everything. I'm Russ Altman, and I'm speaking with Dr. Newsha Ajami about her work in water supply and the changing dynamics, so to speak, of water. You mentioned it earlier, that a very attractive and compelling idea that everybody in the chain is responsible. And I know that some of your work has been about usage patterns. Mm-hmm. And in fact, there was, so many usage patterns are just going up and up, more and more electricity, more and more batteries. But I believe that for water, you've had it's been a more complicated story where in some cases people aren't using as much water as they used to, say 20 or 30 or even 90 years ago when, during the Depression, they had all these major public works projects. So can you tell us about that?
Sure, absolutely. Actually, that's a very important point of this whole equation, which is the way we plan for future is always population grows, demand grows. especially when it comes to water. So there's always this assumption that as cities grow, as population grows, we'll see more demand on our water supplies. What we have seen in the past 50 years is actually the opposite. Not the opposite, basically decoupling of these two. You can see as population is growing, demand has not been growing. We are actually in some of the major cities, for example, Los Angeles, we are taking as much water as we used to in 50 years ago, but the population almost doubled.
So you're not just saying that the per capita usage, but even the total usage is down, even though presumably the population has gone up.
Total usage is steady.
Okay.
Per capita usage has gone down.
Okay. And what do we attribute this to? Yes.
A lot of efficiency systems that we have put in place. So as you know, as a lot of the appliances we depend on, for example, they are very water intensive, dishwasher, washing machines, and so on. So we have become much more efficient in the way we are designing these systems to use less water. Funny enough, that actually partly was driven by energy efficiency, because we use a lot of energy to warm up that water to wash the dishes or wash the clothes. So they wanted to use less water. So that was part of it. Also in our homes, we have become more efficient. You know, the fixtures that we have in our houses, a lot of actually codes and that have been put in place, or ordinances that have been put in place in local places
like for new buildings,
plumbing, you know, all that has become a lot different and more efficient. We are using less outdoors. Actually, interestingly enough, with water, every drought or every natural sort of external environmental stressor that have impacted the system, people have changed their behavior or replaced their appliances, and they actually never gone back up.
We were just looking at pictures of our family 20 years ago when we moved into our home, and we had this big, beautiful green lawn. And I looked at the pictures, and it's been brown for the last 5 or 6 years. And I had forgotten that there was grass there.
Actually, one interesting fact here is that you might not know, but the biggest crop we're growing in the U.S. is lawns, actually.
No.
Yes.
Is that still true?
It is true, yeah. It's the biggest crop we are growing in the U.S., which is crazy because we are not depending on it for food supply or anything that is like essential to our daily life. It's mostly for aesthetic and, you know, comfort and leisure.
Yes. So that makes my mind explode. But at least our front lawn is totally
yours
brown.
Is great. Yours is brown.
And my wife is very passionate about this, in fact. So let me ask about, we recently were looking with our daughter at like where she got her water supply, because we were worried about fluoride and my grandchild and blah, blah, blah. But what I remembered by looking at these maps is that we have a very fractured water supply system. Like she's just 8 miles away, but there's at least 2 or 3 water districts in between the 8 miles that separate our homes. What is the situation with respect to how water is delivered to consumers? And is this system part of the problem, or is it actually a pretty robust, good system that like we can make it work?
That's a great question. Actually, a couple of things there. One, you're absolutely correct. We have a very disjointed, fragmented water system, mostly the way we govern it. Yeah. So you know, I'm just to give you an example, there are about 7,000 water agencies in California.
Yes,
and that number is not even, you know, there might be a little bit higher or lower. It's like right. So uncertain.
Because it's hard to even define what you're looking at.
Exactly. So mobile parks also count as a sort of like a district by themselves sometimes. So this fragmentation is definitely an issue, especially when you are trying to sort of create a change in the system, right? Because not everybody is as flexible to change their behavior or change their model. The second thing that you mentioned, which is important, is we are also disconnected from our water supply source, that often people don't know where the water is coming from, or actually where it goes afterwards. They just open the tap. So if you ask there was a study done a couple of years ago at the University of Illinois that asked people about their water supply and if they know where it comes from. And majority of people said, oh, magic, and then comes out of my tap. So So
There you go.
imagine if you are trying to change behavior, right? If you tell people you have to change their behavior, use less water, it's going to be very difficult for them to connect to it because where is it coming from? Why do I need to change?
That's amazing. Actually reminds me of healthcare, where most people have no idea how much their healthcare costs,
Right.
and therefore they're not price sensitive. But going back to water, because that's the
Yes.
topic. So let me ask a real basic question. So here we have this area where I live, and there's all these water authorities. But are they getting the water from the same big pipe, or are there actually separate pipes for each of those water authorities? Like, I personally have no idea how the water system works. So could you give us like a little primer maybe on like how water gets from whatever reservoir or ground source to the home?
So for example, in the Bay Area,
Yeah.
up to Santa Clara, a lot of the water is coming from Hetch Hetchy, which is
A big flooded valley in the Sierra Mountains.
Yes.
I was told similar in beauty to Yosemite, but flooded now.
Yes, and I have been there. It is truly magnificent and beautiful. So that a lot of our water comes from there. And some of these cities or water utilities have some supplements that they add to it. For example, they have local groundwater that they're adding to their water supply, or other sources, or local reservoirs. They have watersheds that are managing. So our water mostly for this part of the Bay Area is coming from Hetch Hetchy.
And that is a single or a few big pipes from that.
Yes.
But then it branches out or something when it gets
So basically,
close.
San Francisco Public Utility Commission sort of has the right over that water. So they actually have contracts with a lot of different cities so the 26 water utilities in the Bay Area, that they take some of their water from San Francisco Public Utilities. So they are the one who manage the whole system. And there are big pipes involved. You're absolutely correct. That brings the water to us.
As you know well, there's a beautiful reservoir close to Stanford, and it's visually stunning. And I'm a big swimmer, and I would kill to swim in it. But it is clear that they have big fences with barbed wires, and there's no way. But that's on my bucket list, is to swim in that reservoir.
Yes, that water is coming actually. So what they do is they bring some of that water down in different seasons or different times, and store it in that reservoir, and then they distribute it from there to different cities.
This is The Future of Everything. I'm Russ Altman, and we'll have more with Dr. Newsha Ajami next on Sirius XM. Welcome back to The Future of Everything. I'm Russ Altman. I'm speaking with Dr. Newsha Ajami about the water supply. And in the previous segment, we were discussing the sources of the water, how they come from groundwater or from lakes and reservoirs that have long pipes. I think you've written and talked about the diversification of sources of water as one source of robustness. So can you tell us about what does it mean to diversify the water supply?
Sure. To kind of put this in perspective, maybe people would relate to energy a lot better sometimes. Or actually their financial portfolio. It's really important to actually not put all our eggs in one basket and have broader set of options to make sure we can handle different disasters or actually build a resilient future for ourselves. That similar thing applies to water. As we are sort of realizing climate change is impacting our water supply and upstream, it's very important to work with nature. So as part of that, building solutions on the ground, for example, doing more gray water, capturing water and reusing it multiple times, or actually allowing for natural systems to capture water when it rains and then store it for us for the future.
I want to make sure we define what you mean by gray water, because it sounds a little scary.
Gray water, basically. So a lot of the water we use in our homes, they don't get really polluted as much. For example, when you wash the dishes or wash your hands, or when you shower, that water can be easily cleaned up, and then we can use that water to irrigate our yards, or actually the most important thing, maybe flushing down the toilet or using it for a flushing water for the toilets. Because right now what we are doing is we are using drinkable water for the flushing water, which is not very efficient. We use a lot of resources and to make that clean. So, so those are some of the options, and similar to energy that people are putting solar panels on their roofs or wind turbines, the same thing can happen at household level, putting these things, or actually at regional scale. We can have the same way that we have solar farms. We can have some of these solutions at regional scales.
Great. And then by having these different sources, the failure of one or variation in one doesn't make you absolutely beholden to that one source.
Absolutely. And as part of that process, actually, we have to focus more seriously on demand management, meaning that bringing down water use even lower than where it is right now and trying to be more efficient in the way we use water. And our team has been actually focusing a lot on that, trying to understand how we as consumers, what kind of decisions we make, how we are part of this process, trying to actually better understand how different disasters or stressors, for example, droughts, are impacting our thinking or our decisions. So we use a lot of data from different sources, not from different sources. We use a lot of data from I'm sorry, my daughter is printing something. I'm so sorry.
It's okay. It's okay. Hey, so I just tell Ray, who's our producer, Ray, you want to cut out this section, and then you can just start again, Newsha.
Okay, sure. So we use a lot of data from meters, actually. So there are different kind of meters. There are analog meters that they capture data from every month, or there are like smart meters that they capture data every 15 minutes. And we take that data and we combine it with climate data, with socioeconomic data, with actually media data, so many data sources, or actually land use data, so many data sources that are out there that kind of define how we use water. And we are trying to kind of merge these data sources and try to better understand what is impacting people's decision-making process, what factors are involved in the process, and how permanent those changes are. Are we changing our behavior just for a short time or for a long time?
So you mentioned some really interesting data sources, and I want to get to that in a minute. But before that, you also were talking about demand patterns, and I was wondering, is there data on whether we should use carrots or sticks, or is it a mixed bag? Because I know that you described some people who just naturally their water consumption because of awareness of droughts, like you do a switch and you actually never go back to your old way of life. And those are nice stories because those are very much kind of like almost like carrots, like they just came because the people said this is the right thing to do. But you could also do pricing and stuff. Is there best practices in how to manage, or is there data about how well we can change people's demand?
So price is a great example that you mentioned. Also, sometimes there are restrictions at the state level or at regional or local scale that can change people's behavior. But we need both. So there is some data that, a lot of water agencies have changed the pricing patterns from single price to like sort of having tiered pricing to make sure people who use a lot of water to be charged more for water.
Yes.
So there's so many different examples of that. As we talked, there are 7,000 water utilities, and each one of them have their own model that they use.
I remember during a drought, they would give us a little allocation, and then they would show us if we were above or below.
Yes.
And I was a sucker for. I'm very susceptible to these things. So I was proud every time when I was below my target usage, and they gave me a little bit of a red star or whatever, and I just loved it. And so I could imagine there are even little things you can do in the bill to inform people. And they also show you, like, this is April of this year, but here's April of last year, and you want to see if there's and of course, as an engineer myself, I am totally susceptible to those manipulations. But I wanted to also go, so you said something intriguing. You were talking about the data sources you used, and of course, data usage and the billing, but then you said media. I wasn't expecting you to say media, and you were also talking about other unusual data sources. So could you describe why is media coverage, and how does that factor into water usage? That's a little bit of a surprise.
Sure. So actually, during the extreme drought in California that happened just recently between 2012 and 2016, around 2013, 14, I got a call from a colleague that said, we don't know what's going on. We have not changed our and this colleague works for a water utility. We have not changed our, advertisement or, outreach efforts to make people change their water use. at that time, governor had asked people to do a voluntary reduction in their water use. And she was like, I don't know what's going on, but people are not using water. And we want to know what is it? And when are they going to potentially go back to their sort of
if you don't know
old
what
way of
causes
using
it, you won't know when it's going to stop either.
Yes. And another big problem is we charge people based on how much water they use, which is not a very good business model if you are trying to promote conservation and efficiency, right? So basically what at that time, drought was such a big topic, like everywhere in the US and internationally. So there was a lot of media coverage on the drought. So what we did was, so I was like, it's probably media. We should somehow figure this out. And I used to work for the legislature. So I was in California, and I was aware of LexisNexis and ProQuest as sources of media. So we decided to go look at that data and see if we can see any relationship between water use and that. And very quickly we realized the coverage was so much that LexisNexis and ProQuest had not covered, like haven't been archiving all of it. So we actually developed an online scraping tool that had sort of sat on Google API and searched for articles that have been written on California drought.
So you can quantify the amount of coverage, and probably you could often say, is it a positive coverage or a negative coverage based on the word usage and stuff like that?
Yes, exactly.
And what do you find when you look at that?
So what we found was actually media was one of the main factors that impacted change in water use. Media, and then actually we used Google searches as a public awareness measure, because people search, is the drought over? How much should I conserve? You know, all these different terminologies that people use. And so you could see actually as media coverage was going up, so as the searches on Google for related to the drought.
Very interesting. So now, was Google a partner in this research, or is that data available publicly?
That data is available publicly. Everybody can go and see what are the popular searches.
Are people searching about my topic of interest, and in your case,
absolutely,
water? So in that way, the consumers are kind of helping you with the research, because they're helping generate the data that allows you to predict demand and supply in the future.
Absolutely. So basically we use that information to kind of better understand what's going on. And we found that at the time, unemployment was very low, which is conventionally assumed to be a driver for water use. When unemployment is low, water use goes up. And you could see that they were actually decoupled there. Even though unemployment was low, water use was dropping precipitously. And so media was one of the big drivers, and media and public awareness was one of the big drivers of behavior change during the drought. That
is fascinating. And I must say, it's been a theme in this show that the data availability is now impacting fields across the spectrum, including ones you would not expect. Well, thank you for listening to The Future of Everything. I'm Russ Altman. If you missed any of this episode, listen anytime on demand with the SiriusXM app.